for the pre-quiz is draw what's happening on the thing, right? So we start at 175 pascals, 1.6 cubic meters. That's here, and 175 is, I think that's right here, isn't it? Yeah, right? Right, then we cool the thing. All right, no, isobaric constant pressure compression to 0.4, right? So we're going to go to here, and you're going to draw a nice little arrow, you know, there we have it, right? And then we're going to cool it to 50 pascals, right? Then we're going to expand it to here, and then there's our processes, right? This one is process 1, this is 2, this is 3, right? This is 4, yeah? You would think that the answers would be somewhere, wouldn't you? Do you know where the answers are? Do you know where the answers are for this? Where? They're on the back. Nothing on the back. There's nothing on the back, and that's because when I sent it to the print shop, I just said it's a one-sided copy because I forgot there was a back. I know. That's sort of sad. And so the answers are not there, but I'll put them up in a sec, right? Okay. And then the question is, how does one... Do we have questions about number 3? It was, I believe, just draw a PV process. Are we good on that? Okay. So then the question is, how do you calculate the temperatures of those? And the way you do it for number 1, calculate the temperature of at the end of each process. So for every corner, right? The thing to do is just use PV equals nRT. Notice that I tell you N is at the top there. It says 0.28 moles. Right, R is 8.31. This is moles. Right, this is 8.31 joules per mole Kelvin. Right. Temperature is what you're calculating. Pressure and volume you read off the graph. Does that make sense? Yeah.
Oh, I have a question. Is the
give yourself more than one. Oh, you already did. Okay.
Is the Newton's cooling lab? Is that going to be on this?
Yeah. Let me talk about that in a sec. Yeah. Yeah. Okay. So. That's number 1. Number 2 and number 3. Number 2 and number 3. I like this. 2 people are paying attention to me. Okay. For number 2 and number 3, the answer is you got to use this formula. Work is pressure times change in volume. And of course, when there's 0 change in volume, there's 0 work done. So these vertical bits are the ones where there's no work done. And the reason why is that for the example of number 4, basically 4 is just pressurization. So 4, the process looks like this. It's like, but it doesn't actually move, right? Yeah? Right? And number 2 is just depressurization. So it starts up, then it goes, but it doesn't really do anything other than that, right? Yeah? Okay. But these ones, like 1 is a compression, 2 is or 3 is an expansion. So those guys do work. One of them is negative, one's positive, right? And then the net overall work done by the cycle, just add up number 3, right? One's positive, one's negative. You'll end up with something, right? The answers to this, all I did was I went to the website and just grabbed the document off the website, and there's the answer, so you can check that. So the answer to 2 is 2 and 4. The volume doesn't change, right? 1 and 3 does work, and the work is, yeah, he's here. Negative 210 for process 1. Positive 60 for process 3. The net work is negative 150, so there are the answers there. Shut up.